Selamat sejahtera, my name is Yang Xian. The paper that I'm going to talk about is Improving Reinforced Soil Performance Incorporating Vertical Reinforcement, written by Bino Streta and Hadi Kabat in 2010. Summary. The paper proposed applying vertical reinforcement along with conventional horizontal reinforcement as a new concept of soil reinforcement. The main objective of the vertical reinforcement is to stitch horizontal reinforcing layers to each other. The improvement in reinforced soil technology can be tackled the different mode of failures such as bearing capacity, tensile overstress, and pull-out. The insertion of vertical reinforcement provides resistance against shearing to make all the layers intact that will increase the strength and stability of the reinforced soil. Vertical reinforcement also enhances the tensile strength and reduces the induced tensile stress in horizontal reinforcement. Vertical reinforcement not only ties each layer to another, but also encounters some components of tensile forces and increase frictional resistance, rising anisotropic cohesion and friction angle. Societal, health, and legal issue of the improvement techniques. For societal, the improvement of reinforced soil performance bring benefit to the current industry of soil reinforcement. For health, this concept allowed the construction of a structure without excessive surface deformation or stability defects. The failure of such will lead to a safety health risk of people in a building. Legal. Country has different requirements of soil reinforcement for vertical and horizontal reinforcement element in a construction project to ensure the stability of the building. Theoretical background. In the proposed design concept, the theory is based purely on soil confinement to create a high-capacity load-bearing structure. For this proposed design to achieve the required condition for soil confinement, geotextile will be used as horizontal reinforcing layer, which provide bearing capacity, depth, rotational failures, and stability. High-strength polymer rope will be used to stitch the horizontal reinforcing layer together to form a vertical reinforcement which provide lateral root resistance through passive bearing force of vertical reinforcement. The theoretical analysis predicts strength aggregating against bearing capacity, tensile overstress, and pull-out failures. Discussion. This design can help shape the construction industry for various applications, such as rootwork, as it not only provides bearing support and stability to the soil, but also receives lateral root through vertical reinforcement. Further experimentation on the proposed construction process for this soil reinforcement is required to test its reliability and workability for market usage. This design has its own limitation as it has a lower lateral root resistance compared to the mechanically stabilized earth MSC wall, which offer a much higher stability and lateral root reinforcement. Although this design may be significantly cheaper than MSC walls, but when it comes to certain projects that require a much greater stability on lateral root, MSC wall will be much more practical compared to this design. Recommendation. Further study can be done to gain validations based on in situ performance. A rigorous numerical modeling and experimental testing could be carried out to determine the reinforced soil behavior that incorporating vertical reinforcement. Geocell can be added as an alternative for this design. Geocell are 3D sheets of HDPE membrane of geogrips that can be easily handled and manufactured in bulk. Geocell are uncomplicated to install compared to the proposed design which require additional time and manpower or stitching process. Geocell confine the infilled soil by cell or cellular confinement such that the combined system can provide significant load-bearing, lateral root resistance, and stability. Thank you.